Now let us have some examples of using joint characteristic function so that you become a bit more familiar. So assume that you have two independent random variables and assume that they have Poisson distribution with parameters a and b respectively. So remember that we have calculated the characteristic function of a Poisson distribution. This is with parameter a. So remember that probability mass function, probability that x equal k, was equal to e to the power of minus a to the power of k factorial, and the other one, probability of y equal to, let's say, l, is equal to e to the power minus b, b to the power of L divided by L factorial, and k could be 0, 1, 2, etc., and L could be 0, 1, 2, etc. So if you calculate the characteristic function and then take logarithm of that, the second characteristic function for x becomes equal to these, for y becomes to these. And because they are independent, I could say that the characteristic function of the second characteristic function of z becomes, at omega, becomes equal to the characteristic function of x plus characteristic function of the second characteristic function of x at omega plus the second characteristic function of y at omega. And this one is equal to a e to the power j omega minus 1, and then plus b e to the power of j omega minus 1. Now, if you add them together and simplify, this is equal to a plus b times e to the power j omega minus 1. So basically, these represent a Poisson distribution, because this is a Poisson distribution with parameter a, this is a Poisson distribution with parameter b, so therefore the sum is Poisson. So thus z has a Poisson distribution. This is a Poisson distribution with parameter a plus b. So if you add independent Poisson random variables, the sum become Poisson, and the parameters is the sum of the parameters. So if I ask you what is probability of z is equal to, let's say, m, is going to be equal to e to the power of minus a plus b, and then a plus b to the power of m divided by m factorial. Very quickly we can calculate this one. So a summary, this is the second characteristic function. So it is a Poisson distribution, and the sum of independent Poisson random variables is also a Poisson random variable. So z can take values from, let's say, m equals 0, 1, 2, etc., but then the probability mass function you can calculate. The parameter of the sum is the sum of the parameters. Now, if you add 5 independent Poisson random variables, you get similar results, because of the second characteristic function is going to be sum of them. Now we are going to have another alternative ways for studying the joint distribution of two random variables.